Hello and welcome to the June 2018 webinar from Dyalog. My plan today is to show you or demonstrate a collection of tools that are included with Dyalog APL on all platforms, so Windows, Linux, on the Mac as well, which we can use to acquire data online and convert it into APL arrays that we can then analyze and chart and so on. Before I get into that, I'd like to spend a minute talking about our plans for after the summer. This is the 12th webinar that we've produced, and when we say webinar we think of an interactive or reasonably interactive presentation lasting somewhere between 30 and 60 minutes on some topic which is interesting currently. And our intention is to continue to produce about 10 of these a year. What we have realized though is that there's probably also a market for significantly shorter presentations just focusing on a single feature or technique of Dyalog APL, not necessarily something that's introduced in one of the latest releases, but something that requires an introduction, something that people are frequently trying to learn or use. So our plan is after the summer to start producing roughly 10 of those a year as well. So hopefully that will be a good mix of material. And you can really help us by suggesting topics that you'd like us to produce for both types of presentations, both the webinars and the shorter webcasts. So I look forward to emails from you all with good ideas for those. Sometimes the hardest part is to come up actually with the topic for the next webinar. So you can really help. Right, the agenda for today. Originally the title only mentioned XML and JSON because those were sort of the hottest topics. But as soon as I started doing a bit of research and preparing the demos, I realized that a lot of the data that's out there on the internet is actually still in CSV or comma separated value format. And we have quad CSV to deal with that, so that's been added to the webinar today. So what I'm going to do is quickly review the data formats, remind ourselves what they look like, what kind of data there's in them. Then I'm going to go through each one of the system functions, quad CSV, quad XML, and quad JSON. And then when we've become comfortable with those, we're going to go out on the World Wide Web and retrieve some data in all formats using HttpCommand, which is a general tool included with Dyalog APL for retrieving data from web pages or interacting with web services. And of course we're going to try and have some fun with the data, maybe even chart it as we go. Right, so probably most of you are familiar with these. Certainly the first one, this is CSV or comma separated value, I think a very old format. I'm not sure when files started to appear in this format. It must be decades ago. They've been sort of the most common format produced by spreadsheets. 1960s, Richard holds up a sign for me here. Yeah, decades, that was true. Spreadsheets, database, export and import format. CSV has been the probably the most widely used data exchange format for a very long time. So we're going to download some of that. Oh, sorry, the data that we're looking at here, which we're initially going to look at, the same data in all three formats, is some sample data I found on my hard drive. It contains 12 books, information about 12 books. Each book has an ID, an author, a title, a genre, a price, a publication date, and a description. And of course, in the comma separated value file, those are just separated by commas, as the name implies. Some CSV files have a header line with column titles. That isn't always the case. Sometimes values are quoted, sometimes they're not. Sometimes it's separated semicolon rather than comma, but they all go under the name of CSV. The advantage of CSV, besides it being very widely used, of course, is that it's quite compact. There's not a lot of decoration in them. The values are just there with commas in between them. Of course, the downside of that is they can really only be used to represent a very regular sort of flat table structure. The next format we're going to look at, XML, Extensible Markup Language, became very popular dangerous to hazard a date for that, but certainly they were very popular around 10 years ago, probably peaked now. The advantage of XML over CSV, of course, is that you can represent any structure in a self-described fashion. The values are surrounded by tags that make it very easy to identify to provide names, and then you can add style sheets and other descriptive files to XML. There's a whole ecosystem for that allows you to validate and convert XML files. We're not going to be doing any of that today. We're just going to be downloading them and extracting data from them. The downside of XML, it's quite a heavy, sort of bulky structure. There's a lot of additional text, and it's hard to process them very efficiently. It's all quite large. The last format, JSON, which stands for JavaScript Object Notation, is a notation that's become popular in the last decade or so, popularized by the JavaScript language, where it's used really. This is really executable JavaScript notation to a large extent. So it's the way a JavaScript programmer would declare constants or represent data in their application. It's quite nice compared to XML in that there's a little bit less fluff. The notation can represent arrays, so the square bracket that we see up at the top left here says that this is an array, and then the curly braces are objects. We also have the type information, not very complex one, but you can see here that the number here, which is not in quotes, we know that that's a number, and we can convert it to a number in APL when we read it because of that. So those are the three formats. And with each one of them, there is now a system function in Dyalog APL. But before we look at the definitions, we're going to dive straight in and try doing some work with those files. So here's an APL session. This is version 17, beta 2, about to be released any day now. And there's a folder here. These files will all be available for download from our website after the webinar, if you want to try and repeat any of this, the demo scripts as well. So I have a folder, and I can use the quad n info system function with a variant of 1, meaning allow wildcards, to see which files I have in that folder which have a name books with some extension. And unsurprisingly, I have one in each one of these three formats. If as a left argument to ninfo I provide 02, that tells me in addition to the name 0, I want the fact number 2, which is the size, so I can see the relative sizes of these files. And we can see that the CSV is the most compact and the XML is the largest. So let's have a go at reading the CSV file and converting that. So here's the name of the CSV file. And before we look at the three conversion functions, we can see that just quad n get, which is also a fairly recent cross-platform addition to Dyalog APL, works the same on all platforms. If we just give that a file, it returns a 3-element vector. First, there's the text. So here, because the file is not very big, that just fits on 10 lines of output in my session. And then the second element of the nested array returned by nget is the Unicode encoding, and the final element is the line endings that were found in the file. If instead of passing that file name to nget, we pass it to quad CSV, the default behavior is simply to read the entire file and convert it into a matrix. There's some guessing being done as to data types and so on, but in this case, because of the header line, it's all just been returned as a matrix of character vectors. No type conversion was done. Now, quad CSV allows us to provide additional information if we don't want to read the entire file and if we do know something about the data types. So this vector of column encodings here. 0 means ignore a column. So we're ignoring the ID, reading author and title as character data, ignoring genre, reading price as a numeric vector, and then ignoring the last two. we want to let Quad CSV know that there is a header row. We don't know what the Unicode encoding is, so we just set that to empty, and we can now call Quad CSV with these 4 arguments: the name, the encoding, the column declarations, and the header. And we now get back a 3-column matrix, and we can see it's 12 by 3. And because we provided information that the 3rd column was numeric, it has been returned as a set of numeric items, a numeric column, and we can do calculations in APL like compute the average price. So Quad CSV is designed for working with very large volumes of data, and one of the things that it allows you to do to help with that is to invert the data. So if we use the variant invert and inversion type of 2, we get these 3, we get the matrix that would have been 3 columns, we get that returned as 3 vectors, which often leads to a significant reduction in the amount of storage, and also makes it easy now to refer to these columns using their names. So here we can extract we can do the equivalent of an SQL select author title from books where price equals maximum price by searching for the max reduce of price, finding the index, and selecting the author and title from that. So there's the most expensive book. Quad CSV can also work on in-workspace data. So if you're not reading data from a file, but you receive data via a socket or something like that, instead of the file name, you just pass the data itself. In that case, you need to provide the format, instead of being the Unicode encoding, is a flag to say whether it's nested, in this case, a vector of vectors, or if what we had was a simple character vector with embedded new line characters, S means it's simple, and Quad CSV can do that conversion as well. And it's bidirectional, so if we have a matrix of data and we put that on the left-hand side of Quad CSV, we don't have a file name because we want to produce output in nested format. We get back a vector of character vectors of the rows that would have been written to a CSV file. We can also provide a file name, in which case the generated CSV data will be written back. In this case, I'm using a variant if exists replace, which hopefully is fairly self-explanatory. That file is already there and was overwritten by that statement. New in version 17, a user command called bracket help, which certainly works with all system functions. So you can say bracket help and get all the help for Quad CSV. We don't have time to go through all of that. Let's move on to XML. So Quad XML doesn't have the capability to read from a file. So there we have to use quad get to retrieve the data into a character vector. So we read books.xml. It's 4,400 characters long. If we look at the first few characters, it's what we saw on the slide before. No surprises there. If we pass that character vector containing XML to Quad XML, we get back a matrix. I'm doing an 11 take here, so we just see the first 11 rows. The matrix has 5 columns: the depth of nesting, the tag name, any content associated with that tag, attributes, if there are any. The book items in this XML have an attribute called ID, and a type which provides information about whether a node has children, various other bits of information about the tree. So in this case, that's an 85 by 5 matrix. If I want to find out how many books there are, I can look in the second column for this text book and do a plus reduction of the Boolean comparison there. There are 12 books. As in the CSV, I'm interested in those 3 columns, author, title, and price. If I search in the third column for those 3 fact names and use that to compress the values, that gives me a vector containing all of the values for those facts. And if I then reshape that into a matrix with number of books rows and the tally of facts columns, I get the same matrix as before, essentially, when I'd used Quad CSV to extract the data. In this case, no numeric conversion has been done. If I want to play with the prices, for example, I decide I'd like to increase all my prices by 10%. So I search for price, use iota underbar to find the indices. So I now have the indices of the prices in the XML matrix. getNum is a little utility I'll define to extract numeric values from strings. If I then multiply by 1.1, round it down to the nearest dollar or pound or euro or whatever they are, and add 0.95, so I get nice looking prices. Replace that back into the matrix, replace the values back into the matrix. If I then run quad XML on the matrix, so quad XML is self-inverse. If you give it a character vector, it returns the 5-column matrix of information. If you give it a 5-column matrix, it returns the XML. So we can see that the new price is in the XML. We could write that back to a file if we wished, but I'm not going to do that. Again, bracket help XML, I'm not going to bring that up because I've been talking a little bit too much, as usual. Let's move on to JSON. Again, JSON, like quad JSON, like quad XML, does not have the ability to read and write files itself. We need to use nget. It's slightly shorter. It looks as it did on the slide. With JSON, we have two choices. We can either, if we use the variant format M for matrix, we can get a result back which is very similar to the result of quad XML. It has 4 columns instead of 5 because there are no attributes in JSON, so we don't need the attribute column. And the type information is slightly different. It's the actual JSON data type. So 2 is an array, 1 is an object, 4 is a string, and 3 is a numeric value. I generally prefer, if I know the structure of the data, and sometimes if I don't, I typically use JSON without the format option. In that case, you get a namespace back, or an array in this case, because the highest level of the JSON was the containing array with the books. So we have 12 elements of that array. If we use the map user command, that's something which you can point at any namespace, and it's going to try and tell you to try and navigate down the structure as far as it can go and provide information about what's in there. We can see that we have these names inside, and I can select the first one and dot into it and simply refer to the variables that were in the JSON by name, because the JSON object, the array of JSON objects, has been converted into an APL array of namespaces. So I can use very much the same structure the same notation as in JSON. One difference in APL, of course, is that if you have an array of spaces, as this JNS is, it's a 12-element array of namespaces, and you type a dot, an ID, that means execute that expression ID within each of the spaces, so we can retrieve all of the IDs in that expression. We can retrieve the prices as a vector by just typing jns.price, and we can do that price adjustment using a very simple APL expression. The price is already numeric, we can just do the multiplication. The prices have been adjusted, and we can use quad JSON. It's also self-inverse most of the time. There is a left argument where you can specify which way you want it to go if there's any doubt. Generally, if it's a string on the right, that's assumed to be JSON. If there's anything other than a character vector on the right, it's assumed to be an APL array that needs to be converted to JSON. This is a little bit compact, so I use the compact variant, set it to 0 to get uncompact or pretty printed JavaScript. So that also goes the other way. One of the things we found after implementing QuadJSON in APL is that if you have an APL namespace like this little one I've created here, using QuadJSON on it is actually a very convenient way to get quite a compact display of what's inside that array, as long as there are no two-dimensional structures or higher dimensional structures. Richard, I didn't actually have time to read what you wrote there. It's gone.
It's gone. I'll bring it back.
I was about to pause.
The moment has passed.
Yeah, okay.
Just then.
All right, so that was right, so a question has come in about whether anybody has thought about writing code which would take an XML input like the one we've just been looking at and essentially do what QuadJSON does, so figure out a sensible structure for it. No questions asked, come up with a good representation. We have thought about that very briefly. There's a workspace that's distributed with Dyalog APL called load data, where there is a function called load XML, which if presented with the data that we've been looking at here would be able to turn it into a matrix. It just looks to see whether there's a completely regular structure of essentially column names repeated over and over again, and if there are, it turns it into a table. I don't know if anybody's tried going any further than that. I mean, that one is very simple. Anything further than that, I think, would be a bit complicated. And everybody's moving to JSON anyway, or are they? Right, so that was the first demo. So to quickly summarize before we start, or we go off and do what we really want to do, which is extract data from the internet. So Quad CSV has been in Dyalog APL since version 16. It has specifically been designed to work with importing and exporting large files. So the reference to the CSV is sort of the default is that you give it a file name and it processes the entire file. But you can also tie a file and then give it numbers of records to read, and it'll read blocks and maintain its position in the file. And then you also have the option of providing data that you already have in the workspace. The APL array, you have a choice of a matrix corresponding to the table, or inverted arrays, either a vector for each column, or you can also elect, if there's character data, to have each character column represented as a simple character matrix. So there are options to select exactly which columns to import and specify the data types, and it can read and write CSV sources. Quad XML is actually the oldest of these functions. It's been there since version 12.1. Unlike CSV, it doesn't read or write files. It produces or consumes this 5-column matrix, a tree representation of the data with a level of nesting, element name, content, etc. When you're going the other way, if you're generating XML, you don't need to provide attribute value, name value pairs, or row content descriptions. So it's simpler. You don't need to provide information which there really is no equivalent for in APL. And JSON, the newest, although I mean QuadJSON came into APL in version 16. A model using I-beams appeared for the first time in version 14.1. You have the choice of the XML style matrix with columns or an APL namespace. There are a few interesting things about mapping JSON to APL namespaces. For one thing, JSON can have names which are not valid APL array names, or wouldn't be valid names in APL workspace or namespace, and those are mangled. So for example, we're going to look at an example in a moment where we have a date which is used as a name in JSON. And what we do there is we convert the hyphens, which are invalid, into these delta underscores and then the Unicode number of the character that's been converted. Right, now for the fun part. Using this on unpredictable data that we're getting off the internet. So we're going to use a tool that's been in Dyalog APL for the last couple of releases. It has improved very significantly in version 17, and in fact even if you're using the beta 2, you may want to go to GitHub and get the very latest one while you wait for the 17 release, because as we prepared the webinar, as usual, we discovered a couple of little glitches. So HTTP is the protocol that's used by web servers and browsers when transferring data. So you use it all the time, even though you may not think of it very much. The thing that's by far the most widely used is an HTTP GET, which is what a browser uses when it goes to retrieve a web page or download a file from the internet. There's something called an HTTP post, which is the message that gets sent if you submit a form. And this HttpCommand utility, which is included with APL, is a general tool that can make all kinds of HTTP requests. In this webinar, we're only going to use the GET, so we're not going to go into a lot of detail about how HttpCommand works. So the real challenge with preparing this webinar has been finding some interesting data. There's an enormous amount of data out there. If you Google, you'll find hundreds of thousands or millions of different data sources. Kaggle.com I found was an interesting place. I didn't actually end up using any data from there, but just an example of one of the very large collection of sites where you can find data. Obviously, if you're in a real setting doing some research or some work, you're presumably working with some data that's been provided to you for a purpose, and you don't have the problem of finding something that might be interesting for your webinar. So let's have a look at what we found. So HttpCommand is provided with the APL interpreter in a script form that's loaded with bracket load. It's in a location where by default the system knows how to find it, so you don't have to type anything more than just load HttpCommand. It has a description which tells you that, as we already know, it's a standalone utility for issuing HTTP commands. There's a lot of documentation included if you look inside it. Since we're only going to be doing gets, we're not actually going to look at that documentation. If you don't have the very latest version 17, here's a command line you can type to actually go to GitHub, retrieve the latest version of HttpCommand and fix it in your workspace. Fortunately, I don't need to do that, but here's the documentation for using HttpCommand, in fact, to upgrade itself. CSV. So this is where I realized the first place I ended up when I went out to search for data was on US government open data. And that's when I discovered that we needed to talk about CSV as well, because the first thing I found, and in fact a large number of the things that I found, were CSV data. So here's a link of something, population by country for 31 years. And there's a link here which will actually download a CSV file. What I'm going to do instead is I'm going to right click on that, copy the link address, and then I'm going to type that into a variable. So here's a link that I found on that page, which is simply a link to, you can see at the end of it, it says .csv, so that's a CSV file. And we have it also in the script in case I wasn't able to do that. So all we need to do to retrieve the data is to say HttpCommand get and pass it the resource locator. And what this returns is a namespace which has a display format in version 17. It looks a little bit different in 16 in 17 this has been improved so that it shows us without us having to dot into the namespace that the return code was 0, the message was empty, the status is OK, and the shape of the data is 59,000 bytes. In fact, what's been returned is a namespace with a bunch of properties that tell us a bit about how this request went. We don't really need to look in there unless we're curious, but one thing which might be worth looking at in this context is we can see, if we look in the headers, that a content type is declared, and the web server seems to think also that this is CSV data. In fact, we could write a little expression just to extract the content type from the headers if we wanted to. If we just use the editor to look at the data variable inside there, which contains the data that was returned, we can see it does indeed seem to be CSV data. And if we pass it to quad CSV and declare that it is simple data, we in fact very happily get 233 rows and 32 columns of data. If we add the information that the 31 last columns are numeric and pass it to quad CSV, we get this matrix where the first column is names of things, the first row is years, and the rest of it is population data. So that's all we're going to do with that for now. We've retrieved data and turned it into a matrix. If we have time at the end, I'll try and have a little bit more fun with that data and maybe chart it. XML, I can't remember how I ended up on this page, but there's the URL. It doesn't have a very descriptive name. This is a bit suspicious looking, rows.xml. But there it is, and that was 8 megabytes. So if you have a good internet connection, it doesn't take very long to take stuff off the internet. If we have a quick look at that, oh yeah, it does indeed look like XML, doesn't it? Not very appetizing. The headers seem to agree that it is XML, and if we pass it to quad XML, it works, and we get 210,000 rows of data. And what it turns out we have in here is some, I think, census data from New York City, where they've collected for newborn children in for 4 years the ethnicity, gender, and the name, and there's a frequency count as well, the count of children that had that name, and a ranking. So there's a bunch of rows and 5 or 6 facts. So this little frequency tabulation function here with key allows us to find out how frequently things occur. If we call that, for example, in a vector like this, we can see that there are 2 reds, a blue, and 3 greens. If we call it on the level of nesting, we can see that there is 1 item at the top level, there's 1 item at the second level, these 2 things called response and row. There are 30,000 entries at level 2, and then the facts 180,000 at level 3. Isn't that interesting? If we look at the tags, so that the names of the leaves, we've got 1 response, we've got 30,109 rows, because in addition to each row there's something at the top level called row, curiously. But then it's very nice to see that we have exactly the same number of all of the other facts all the way down. So this is a completely regular structure that we can now reshape into something more useful in APL. So if we take out all the distinct elements, so the tag names in the second column, and we drop off the first 2, which we know are uninteresting, the response and row, we have these 6 facts that we are actually interested in. We can then count the number of rows simply by counting the number of occurrences of the first fact, plus reduction of the tags member of the first fact. And we can then filter on whether the second column is a member of one of the facts we're interested in, use that to compress the data. Pretty much the same thing as we did with the books earlier, and reshape it into a 30,108 by 6 matrix. So we now have something that looks like this. In order to be able to refer to the columns by name, I'm going to create a namespace that I want to put things into, and I'm going to generate an APL expression where the names of the facts are here in parentheses, and then there's an assignment and a split of that matrix, so the 6 columns get assigned into 6 variables inside the data space. I'm going to execute that, and now we can see that we have a data namespace containing those 6 variables. The length of data.gender is 30,108 as expected. We have 2 genders. That's a bit surprising, I suppose, for data from the US these days. We can use the getNum function. This is XML data, so there was no information about the types. So the rank and the count, in fact, as well are character vectors, but I can convert the rank into a 30,000 element numeric vector. We can do a frequency tabulation on the ethnicity. On the birth year, and at this point it starts to feel a little bit questionable, because it seems a bit unlikely that there would be twice as many births in 2011 as 2012. So you have to be a bit careful about this stuff you scrape off the internet. If we do a search, so now we dot into the data namespace, and inside it we execute this expression where we create one Boolean vector searching for the gender being female, the ethnicity being Hispanic, and the rank being equal to 1. So we're trying to find in each year the most popular female Hispanic name, and use that to compress our matrix. And at that point we can see that there's something seriously wrong, because years are appearing more than once. And at this point I sort of lost interest in the data. I did a distinct on the rows, and we can see that there are repetitions. And but I mean, what this demonstrates is that it's quite easy to get hold of data, and it's also quite easy to quickly, interactively figure out whether the data seems reasonable and it's something you should carry on working with, or whether it needs some significant data cleaning activity before you proceed with any analysis. This is one of my favorite sites that I check regularly to be sure that everything is okay. There's an XML resource on has the Large Hadron Collider destroyed the world yet? And again, this demonstrates just how unreliable all this data is. I mean, it's all very well that we can say, you know, what is the content, and it's nope. But if you look at the data, you can see they haven't updated it since 2011. So it's very questionable.
We are still here.
We do seem to be here, so maybe they only update it when the state changes. I'm not sure. Okay, finally, let's grab some JSON data off the internet. The XML and CSV is something that you very often get back from static content that you get back. If you're talking to a web server, a service, which is what we're going to do here, it's much more common for the format to be JSON. So here's a date that we're going to check. We're going to go to NASA. They have a web service where you can get information about near-Earth objects. So we're going to prepare a little namespace here with parameters for our web service call. There's a start date, an end date, and then there's an API key, which allows us a very small number of requests each day. Hopefully I haven't overrun that so that the webinar comes to a grinding halt. I issue the get command, this time passing not just the URL but also this namespace of parameters that are going to be converted to JSON and and passed up to the web service. We get back 13,800 bytes. It is indeed JSON, as we expect. It looks like this. So one of the nice things about JSON is you can quite quickly just eyeball it. I mean, it's similar to XML, but a little bit nicer, and see what the structure is. So we have an object. We have near Earth objects, which contains an object for a particular day, which contains an array of links, and then we have information about how bright it is, how fast it's going, how big it is, how much it's going to miss us by, and of course this very important one here is potentially hazardous asteroid. So we can retrieve that in the matrix format as we saw before, but in this case it's really much nicer to have it as a namespace. So quad JSON without the variant gives us an object, and we can look into that using map, and we can see some of the structure that we saw there before. I'm just going to go in and get that near Earth objects sub-object, and inside there we have this nasty mangled name, and I'm going to work my way around that simply by getting the list of the names, raveling it and executing it. So that way I get a 9-element vector out, which is the content of that array. If we look at the first item there, we can see that it has all of these sub-facts. The close approach data, whether it's potentially hazardous, and so on and so forth. If we look at the close approach data, we can see more information about what's in there. So the really nice thing about JSON is that we can map it to an APL namespace, which is also self-describing, and all of the structure from the JSON data is there for us to easily pick our way through. So if we then into the list of asteroids, we dot and we use this expression here, we get hold of the name, whether it is a potentially hazardous asteroid, and then we go into close approach data and get the miss distance in kilometers. We get this table. We can, unfortunately, for some reason, the distance in kilometers is encoded as a string value in here, so we have to use getNum to turn that into numbers. We can then use this train to compute the index in the right argument of the lowest distance, and so that gives us an index into the table. If we then pick the closest one of these near Earth objects, one of the properties of it is a NASA JPL URL, which is a link that we can use. We can inject that and we can create an HTML renderer which will render HTML on our desktop, and we can direct it to NASA's web page to get information for that particular asteroid. So we're now embedding NASA's application, if you like, here on our desktop, and it's really cute. It has things like this orbital diagram where we can load that object and we can drive it backwards, forwards and backwards, and so on. So that's really cool stuff. Okay, right, now is there time for the chart? I think there is. So let's actually just return and continue with the demo. Do some of our own charting. So if we return to that CSV data that we had originally, retrieved this CSV data, converted it using CSV into an array with 31 numeric columns and 1 character column. And when you look at that, you discover that, oh, we can't, this is not immediately usable because it's a combination of continents like North America, and the grand total for the continent, followed by the countries in that continent, with no indication of whether something is a continent or a country. But fortunately we are using APL. So if we grab the last column and drop the year and the world total, we get this vector of the populations in 2010, the last year of values. If we then compute a running total for everything except the first one, that's easy to do with a plus scan. If we then compare that to the population for North America, we can see that after 6 countries, we reach a point where we have a value which is equal to, greater than or equal to the total for North America. Which means that if we write an expression like this one, it tells us that the first continent there consumes the first 7 rows of data. If we then embed that in a little recursive defun, so we take this expression here which computes how big the first continent is and returns nothing if we've reached the end of the data, and then call that recursively on the rest of the data, we can compute the size of the continents. So that allows us then to extract, if we do a plus scan on that and offset it by a little bit, we can extract the rows of data that correspond to the continents. We can then pull up our chart wizard, SharpPlot chart wizard, and something's gone terribly wrong with my resolution here, but I'll click on, I know which button to click on, fortunately. So it takes a guess at, just based on that 3-column matrix that it got. It's written a little expression here that extracts columns 2 and 3. And we can go in and make some changes. Let's see what would be sensible. We can put in a heading and say population 2018 to 2010. Oops. There we go, and so on. And we can use, we don't have enough time really to mess around much with this, but the nice thing about the chart wizard is it gives you access to go in and look at the, set a key, manage the axis, set all the various settings on this chart, and when you're done with that, you can get it to produce a script for you, which is an APL function that would produce that chart. So here's the code required to produce the chart over on the right hand side. And I've had some help from my good friend Brian Becker, who has a bit more experience with SharpPlot than I do. And he wrote me this little population chart function that makes a nice chart that I'll show you in a second. So if we call population chart on the data, what Brian starts by doing is computing a growth ratio from 1980 to 2010 by dividing the third column into the second one, and also adding onto the bottom the grand total for all of the continents. We fire up SharpPlot, set a frame on which to draw, set up some fonts, set the X labels using the names of the continents, the first column of that, set a heading. Then we're going to draw a pie chart for the first year and the last year. So the first one, we set some tasteful colors that Brian has found through experimentation. We set the center position of the first pie and its radius, and draw a pie chart at that location using the second column, the data from 1980. Then set a different pie center, adjust the radius by taking the world, so the last item of the growth, which is the ratio that the entire world's population grew by, taking the square root of that because we want to change the radius. The area is going to be the square of that, multiplied by 70, which was the radius of the first chart. So we're going to get a pie which has an area, the right area. Draw another pie chart, and then we're going to have a table in the middle of all of this containing the percentage growth for each one of the continents. Set the table position, set the Y labels to be all the continents with world tacked on the end, and the labels to be the percentage change, and then a bit of style information about fonts to use in the table. Draw a table, render the result as SVG, create an HTML renderer window and insert the SVG into that. So again, this is something that in version 17 will work on all platforms, not just Windows where I am at the moment. And we get a composite chart produced using SharpPlot with the 2 pies and a table at the bottom. It's quite cute. I like the colors. Okay, so that's all I have really. No questions. So I hope I have managed to convince you that HttpCommand first of all can be used to retrieve content from many websites, and that most of the data that's out there today is going to be either in CSV, XML or JSON format, and we have the tools to convert that to APL arrays that you can use for analysis, charting and so on, and that can actually be fun. And I'd like to thank people who had a lot of input to this. Brian in particular, who wrote HttpCommand and produced many of the examples that you've seen now. Richard Smith implemented most of CSV, XML and Quad JSON. Very useful little things. Of course, quite a lot of people at Dyalog had input to all of this. And of course, thanks to Jason for running the webinar machinery, without whom you wouldn't be seeing me at all. Still no questions. So either people are bored. Got a date for the next one. Well, I'm glad you asked. So our plan currently is to skip the next webinar, which would have been webinar number 13, the July webinar. And it's not just because many of us are going to be out of the office on that date and it was hard to find a volunteer, but it's also because we're going to start work on producing the webcasts, try and build up a bit of a pipeline so that we can start feeding those out to the world as well as the webinars themselves. So this is a really good time to provide us with input on the webcasts that you'd like to see, in addition to ideas for webinars as well, of course. The next one that we have planned is Brian is going to take the last example you've seen here and various other examples and show much more about using SharpPlot cross-platform as a tool to produce graphics on all the platforms that Dyalog APL, all the desktop platforms that Dyalog APL runs on. And the September one hasn't been announced, although the date has been decided, September 20th. We're continuing to run them at 1600 British time, which is summertime for as far as we can see. And there are still no questions. So either I was totally clear or completely mystifying, or
All the chat's given up.
sorry?
All
The chat's not working. Okay, well, we'll have an awkward silence for another 30 seconds in case you change your mind, and then wave goodbye. Okay, well, thank you for watching, and we'll see you next time.